Hey there, and welcome. We're about to tackle one of the biggest questions you can possibly ask. What is everything actually made of? Seriously, we're going to peel back the layers of reality one by one and find the simple, fundamental rules that build our entire world. You ready? Let's do this. Just imagine for a second you had the most powerful microscope ever invented. What if you could just keep zooming in and in and in on anything? Your hand, your desk, the air you're breathing. What would you eventually find? What are the ultimate, tiniest building blocks of everything? It's not a trick question, and I promise you, the answer is just incredible. Okay, so the very first step on our journey starts with this really simple but totally powerful idea. Everything, and I mean everything, is made of ridiculously small particles. But here's the kicker. They are never, ever still. They're always moving. This whole idea is called the kinetic particle theory, and it's one of those basic rules that just explains so much about our world. The key word here is motion. You see, how much energy these little particles have, how fast they're jiggling around, well, that's what decides if something is a solid, a liquid, or a gas. And this visual makes it super clear. So in a solid, like a block of ice, the particles are all locked into this tight grid, just kind of vibrating in place. Then in a liquid, like water, they've got a bit more energy, right? So they can break free and slide past each other. And then in a gas, like steam, they have so much energy they just go wild, bouncing off everything completely at random. So what's the secret ingredient that makes all this happen? It's just energy. It's that simple. You add energy, usually as heat, and a solid melts to a liquid. And that liquid boils into a gas. The particles are just moving faster and faster and faster. And if you take that energy away, the whole process just goes in reverse. It's so elegant. All right, so level 1 complete. Everything is made of particles. Got it? But that just leads to the next question, doesn't it? What are those particles? What are the actual Lego bricks that build everything else? Time to zoom in one level deeper. And that brings us to the atom. Yep, for what we're talking about today, this is it. This is the fundamental building block of all matter. And just like a Lego brick has a certain shape and color, atoms have their own specific structure that makes them what they are. And you know what's wild? An atom is made of just 3 simple pieces. In the center, in the nucleus, you've got your positive protons and your neutral neutrons. That's where all the weight is. And then whizzing around the outside, you have these super tiny negatively charged electrons. That's the whole recipe, just 3 little things. So if everything's just atoms, why isn't the world just a boring soup of individual particles floating around? Well, because atoms have a purpose, a mission. Every single atom wants to be stable. And for an atom, stable means having a completely full outer layer, or shell, of those electrons. That's its only motivation, and it's the entire reason that chemistry even exists. This brings us to the really important part. See, most atoms don't start with a full outer shell. They're incomplete. So to get stable, they have to team up with other atoms. And they basically only have 2 ways of doing this. These 2 rules. This is how we get from single, lonely atoms to, well, everything else in the universe. Okay, so method number 1 is what I like to call the give and take method. It's officially called ionic bonding. It's pretty simple. One atom has an extra electron it's dying to get rid of, and another atom desperately needs one to be full. So the first atom just gives its electron away. Boom. Now one atom is positive, the other is negative, and just like magnets, they snap together. And here is the most perfect example. You take sodium, a metal so reactive it explodes in water, and it has 1 extra electron. Then you take chlorine, a literal poison gas, and it needs just 1 more electron to be happy. Sodium gives its electron to chlorine, and in an instant, these 2 dangerous things combine to form sodium chloride, the totally stable, harmless table salt you put on your fries. It is an absolutely incredible transformation. But what if neither atom wants to give up an electron? What if they're both kind of holding on tight? Well, in that case, they have to learn to share. And that is rule number 2, covalent bonding. 2 or more atoms decide to pool their electrons. And by sharing, they both get to pretend they have a full outer shell. This sharing creates a really, really strong connection between them. And let's look at the absolute simplest example. A hydrogen atom has 1 electron, but it wants 2 to feel stable. So 2 hydrogen atoms get together, they each put their 1 electron into the middle, and they share them. And now they're a stable hydrogen molecule. It's like a buddy system. By working together, they both get what they want. Now, check this out. These two simple rules, giving or sharing, they create materials with completely different personalities. The ionic compounds, the givers and takers like salt, they form these huge, strong crystal structures with really high melting points. But the covalent compounds, the sharers like water or candle wax, they form individual little molecules. They're held together more weakly, so they have much lower melting points.
So let's recap. We've seen the tiny particles, we've seen the atoms inside them, and we've seen the two basic rules for how they connect. Now, for the grand finale, let's see just how powerful these simple little rules can be.
So, let me ask you a final question. We've seen different atoms combining, right? But what happens if you have something that's made of only one type of atom, but it just uses these bonding rules in a slightly different way? Get ready for this. On the left, we have a diamond, the hardest substance we know of. On the right, we have graphite, the soft gray stuff inside your pencil. You'd think they couldn't be more different, but here's the mind-blowing part. They are both 100% pure carbon, the exact same atom. So what's the deal? It's not what it's made of, it's how it's put together. It's the architecture. In a diamond, every single carbon atom is locked to 4 others in this super strong 3D grid. But in graphite, each carbon only bonds to 3 others, forming these flat sheets that can just slide right past each other. That one tiny change in the blueprint changes literally everything about it. And that really is the ultimate secret of chemistry. Our entire complex, beautiful, and sometimes chaotic world, from the salt on your table to the water you drink to the diamond on a ring, it's all built from just a handful of simple particles following 2 basic rules for how to connect: give or share. That's the whole story. Which leaves us with one last really big thought. If the whole universe is built on these simple, understandable rules, and if we're getting better and better at manipulating those rules, what happens next? What's to stop us from building literally anything we can imagine, one atom at a time?